Next problem. If angle A and angle B are acute angles such that cos of angle A is equal to cos of angle B, then prove that angle A is equal to angle B. Here angle A and angle B are acute angles, but we do not know whether they are angles in the same triangle or different triangles. So here we take the simple case. We assume that in this method 1, we take they are angles in the same triangle. We assume that they are angles in the same triangle. It is easiest method. If you do not know the second method, at least write this method in the examination, you get marks. Okay, so please note that. So because we are talking about cos of angle A and cos of angle B, trigonometric ratios are defined for right angle triangle. So this triangle must be right angle triangle. Here it is right angled at C. So consider the triangle ABC in which angle C is 90 degrees. Here A and B are acute angles. Given cos A is equal to cos B, we have to prove angle A is equal to angle B. Now what is cos A, my dear friends? Cos of angle A means adjacent side divided by hypotenuse, that is AC by AB. What about cos B? See cos B. For cos B, BC is adjacent side, obviously AB is hypotenuse. So cos B is equal to BC divided by AB. But cos A is equal to cos B. That is, these two fellows are equal means the right side fellows must be equal. So cos A, that is AC by AB, must be equal to cos B, that is BC by AB. These two cancels, we get AC is equal to BC. Right? Now in this particular triangle, AC is equal to BC. These two sides are equal. We have wonderful result. In a triangle, angles opposite to equal sides are equal. So these two sides are equal. So the angles opposite to them are equal. Therefore, angle A is equal to angle B. So method 1 completed. Now let us solve problem 6 using method 2. Here angle A and angle B are acute angles, but we do not know whether these two angles are in the same triangle or different triangles. So here we assume that they are in different triangles. Now what type of triangles are they? Because cos of angle A and cos of angle B are given, means we are having trigonometric ratios. Therefore, we need to consider right angle triangles. So the two triangles are right angle triangles. So consider triangle AMN and triangle BPQ, and in these two triangles, angle M and angle P are equal to 90 degrees. Here angle A and angle B are acute angles. Now given cos A is equal to cos B, we have to prove angle A is equal to angle B. How we are going to prove it? So here the method is we use SSS similarity. That is the method we are going to use to solve or to prove that angle A is equal to angle B. So let us see this method. Now given cos A is equal to cos B, what is cos A? Cos A is adjacent side by hypotenuse, that is AM by AN. Now what is cos B? Cos B is also in triangle BPQ, adjacent side by hypotenuse, that is BP by BQ. Since cos A is equal to cos B, what happens? That is left hand sides are equal means right hand sides must be equal. That is AM by AN must be equal to BP by BQ. Now what I do, I swap these two values. That is BP go to denominator and AN goes to the numerator. Therefore, we get AM by BP is equal to AN by BQ. So now what we do is equate these two ratios to some value, say K, and call it as equation 1. Now since AM by BP is equal to Q, we can write AM is equal to K times BP. Now AN by BQ is equal to K, therefore we can write AN is equal to K times BQ. Very good. That is second equation. Now we are going to use this first and second equations. Now here in triangle AMN, because it is a right angle triangle, we can use Pythagoras theorem. What is that? Hypotenuse square is equal to sum of squares of other two sides. That is AN square is equal to AM square plus MN square. Now what is AN? AN is K times BQ. So it is AN square means K times BQ whole square. AM is K times BP. Therefore AM whole square is K times BP whole square. Now we need to find what is Mn square from this. Mn square is equal to K times BQ whole square, that is K square BQ square minus K BP whole square, that is K square into BP square. So Mn square, by taking K square common, we get K square into BQ square minus BP square. That is third equation. Now in right angle triangle BPQ, we have Pythagoras theorem, that is BQ square is equal to BP square plus PQ square. That is hypotenuse square is equal to sum of squares of other two sides. Now from this we can find PQ square, that is PQ square is equal to BQ square minus BP square. So this is 4. Now this BQ square minus BP square is equal to PQ square. So substitute 4 in 3, that is this value is PQ square. So we substitute here. We substitute 4 in 3. So what happens? We get Mn square is equal to K square into what is BQ square minus BP square? PQ square. So by putting 4 in 3, we get this. Now from Mn square is equal to, we got Mn square is equal to K square into PQ square. Therefore Mn square by PQ square is equal to K square. Now what is Mn by PQ? It is K. See here, we already know AM by BP is equal to AN by BQ is equal to K. Now we also got Mn by PQ also equal to K. So in triangle AMN and triangle BPQ, we have this AM by BP is equal to AN by BQ is equal to Mn by PQ. Now triangle AMN and triangle BPQ are similar. By what property? By SSS similarity criterion. What is this SSS similarity criterion? If you take ratios of the corresponding sides, that is AM by BP, AN by BQ, yeah, MN by PQ, all these ratios are equal, then the two triangles are similar. Therefore, the corresponding angles are also equal. Therefore, the corresponding angles are also equal. So, angle A is equal to angle B.